In this courseware video, we will get our first introduction to the particle system in Fusion 5 by creating a simple fireworks display. We start by creating a new composition and then loading the image called miami.jpg from the courseware Footage Stills folder. View the image in the left display view and you can see that the image is not full video resolution. Rather, it appears to be 720 pixels by 475 pixels. Switch to the Loader's Import tab and change the pixel aspect so that it shows custom instead of from file. Set the pixel aspect to 1 to 1 and use square pixels with this image. Set the render end and global end controls and the time ruler of your composition to 200. Now we are ready to add the particle system to the flow. Every particle system requires a minimum of two tools, a p-emitter, which generates the particles, and a p-renderer to convert those particles into an image. All other particle tools fit between these two tools. Locate the reddish-pink buttons in the toolbar labeled PEM and PRN. Click once on PEM and then once on PRN to add these tools to the flow. The particle emitter's output should be connected to the particle renderer's input automatically. If it is not, go ahead and connect them together yourself. View the p-render tool in the right display view. The p-render tool is unique of all the tools in Fusion. It can produce either a 2D image or a 3D environment. The default is to produce a 3D image, but we just want a simple 2D particle system this time. So select the p-render tool and click on the 2D button at the top of the controls to change this tool's mode. Now switch to the p-render tool's Image tab and change the dimensions to match our background image. That would be a width of 720 pixels and a height of 475 pixels and a pixel aspect of 1 to 1. Every particle system must end in a p-render tool in order to produce useful output. Go ahead and drag the output of the p-render over to the Loader tool. This should automatically create a merge tool and place the particle system in the foreground. Drag the newly created merge into the left display view to display its results. Of course, we don't see much change because we have not yet set up our particle system. Go ahead and select the p-emitter tool, then click on the Region tab in the tool's controls. The region determines the area from which particles are born. The default region is a 3D sphere. We want to create fireworks which are launched from the ground into the air, so we will change the region into a line. The start and end point of the line appear as crosshairs in the center of the image, so select one of those crosshairs in the left display view and then move one near the left edge of the image and one near the right edge. Place them under the bridge where the water meets land. New particles will now be created along the line connecting these 2 points together. We are ready to start setting the particles' behaviors. This is done in the p-emitters tab first, so let's select the Controls tab and have a closer look. Locate and open the velocity controls, and then set the velocity to 0.06. This sets the speed of each particle at birth. We don't want all the particles to have exactly the same speed, so set the velocity variance to 0.03. By default, the particles are at angle 0, which means they run across the screen from the left to the right. We want them to shoot upwards into the sky, so let's set the angle to 90 degrees. We will also set the angle variance to 15 to add a little randomness to each particle's heading. Let's play back the composition and see what we've done so far. That looks like way too many particles for fireworks. So let's reduce the amount born on each frame from 10 to 0.25. The number slider is found at the top of the p-emitter's control tab. A value of 0.25 means that there is a 25% chance a particle will be born on any given frame, or an average of one particle every 4 frames. Finally, let's set the lifespan of each particle to 80 frames. We will also set the lifespan variance to 10 frames. This means our particles will live between 70 and 90 frames each before disappearing. Another look at the playback, and we can see that the amount of particles is about right. Of course, the particles appear as single points only. We need to spend some time setting up the appearance of our particles now. Stop playback and set the current frame to 100 so we can see some of the particles in the view. Select the Style tab and examine the controls you find there. Rather than using a single point for each particle, let's change the style to a line. At first there appears to be little change to the particle, But if we open the size controls and increase the size of the particles from the default value of 0.1 to a much larger 1.2, then the line starts to become evident. Note that you will probably have to type in the value, as the default range of the slider is only between 0 and 1. By entering a larger value, Fusion will automatically reset the slider to a more useful range. We should also set the color of the particles to something more resembling a spark, so open the color controls, then open the color wheel, and set the color to a dull orange. Currently, the line particles are all aligned to lie flat. Let's go back to the Controls tab and locate the rotation controls. Set the rotation mode drop-down menu to rotation relative to motion. This aligns each particle with its own motion, which is handy for situations like this. Look at the playback again. We can see that the particles now resemble the mortar launch that contains the fireworks payload. But the velocity is constant. Gravity is having no effect on our mortars. To simulate gravity, we will insert a p-directional force tool between the p-emitter and the p-render tool. Make sure the p-emitter tool is active in the flow, then click on the Tools menu at the top of the screen. Open the Particles category and select p-directional force. Select the new tool to display its controls and then set the strength of the directional force to 0.006 or 6/1000th. This is a very slight value that will erode the particle's velocity so that they start to fall back to Earth after a short while. The effect is subtle, but makes the particles more believable. Play that back to see the effect. After you are satisfied, stop playback and set the current frame to 100. So that takes care of the mortars. What about the payload? How do we make these particles explode into colorful fireworks? The P-Spawn tool can be used to create just that effect. Make sure the directional force tool is active in the flow, then select the P-Spawn tool from the Tools particle menu. We want to make sure we only spawn new particles at the very end of the particle's life. So before we set up any other controls, change to the Tools Conditions tab and locate the Age Range control. Set the start age to a value of 0.99 and set the end age to 0.99 as well. This will restrict the effect of the P-Spawn to only the last moment of the particle's lifespan. We can go back to the P-Spawn Tools Control tab. At first glance, these controls seem exactly like the P-emitter's controls. This is expected. Both tools create new particles. Set the number to 300, causing the source particle to give birth to 300 new particles. These particles don't need to last very long, so set the lifespan to 35 frames. You will see a new control labeled Velocity Transfer a little further down under the Velocity controls. This slider is set to 1.0. That means that the newly spawned particles will have exactly the same velocity and heading as the source particles. We don't want that this time, so set the Velocity Transfer slider down to 0. We do want our particles to have a small amount of velocity at birth, so set the velocity to 0.015, or 15,000th, and set the variance to 0.015 as well. The particles should explode out into all directions, so set the angle variance to 360. The explosion should also be spherical, so we should set the angle Z variance to 360 degrees too. We will be using line-style particles again, so let's set the rotation relative to the motion. Now change to the Style tab and choose the line style, and manually enter a value of 1.0 for the size control. Go ahead and press play to see the effect of our changes. The explosions look reasonable, but they are certainly not the colorful extravaganzas we expect from real fireworks. To have each particle produce a different color on each frame, we will use the Shake modifier. Open the color controls and right-click on the red slider. Open the Modify With submenu and select Shake. The Shake modifier will produce a random value on each frame. Add another Shake modifier to the green and the blue sliders using the exact same technique. By default, the Shake modifier provides a value between 0 and 1 with a fairly smooth transition between these random values. We never want the colors to get too dark, so we need to adjust the Shake modifiers to suit our needs. To adjust the values produced by the Shake, we select the Modifiers tab at the top of the control window. Here we can see all of the modifiers associated with the currently selected tool. Open the first one and reduce the smoothness from 10 to a value of 2. This will produce a more random set of values. Changing the minimum slider to 0.25 will limit how dark the color will become, by limiting the slider's range to 0.25 to 1. Rather than change those settings manually for the other modifiers, we will right-click on the control header for the shake modifier we just changed and select Copy from the context menu that appears. Now right-click on the controls header for the other two shake modifiers and select Paste Settings from the context menu. If we were to just leave it at that, the three modifiers would end up reproducing the same values on every frame, because they have the exact same values and they're set to use the exact same random seed. To ensure we get different results from each, we click on the Randomize button beside the Random Seed slider on each shake tool. As a final touch, we will add some glow to the fireworks. Add a glow tool by selecting the P-Render tool, then choosing the glow tool from the Tools Blur menu. The default values for the glow will be fine. Go ahead and play back the final result. That concludes our introductory particles video. If you look in the Fusion Courseware Compositions folder, you will find the finished projects from this video, as well as an example of a more advanced version providing additional smoke trails for the mortars.